Thank you. My name is Hal Sriver, and I am a senior solutions engineer here at Unravel Data. So for those that don't know, Unravel Data is a data ops and a FinOps industry-leading observability platform. We are built for modern data stacks like Snowflake and even others such as Databricks, BigQuery, EMR, even Hadoop. So throughout my years as a pre-sales engineer in the data space, I've had the pleasure of working with some of the largest data customers. And most recently here at Unravel, where some of the ones you can see at the bottom of the screen here, I've been helping to solve some of their most complex challenges around cost and performance optimization when using platforms like Snowflake. And today's topic, mastering cost predictability, forecasting, and budgeting strategies for Snowflake. So where I'd like to start out the conversation today is, get my slide ready here. First, understanding what some of the cost challenges are in Snowflake. So what is the current state? What are the hindrances from that FinOps perspective that really prevents us from better forecasting and budgeting strategies? With Snowflake, we have very powerful, unmatched capabilities with data warehousing for things like large-scale data analytics workloads. And the thing is, its cost structure is inherently complex. Snowflake's pricing is based on multiple components, including compute, storage, cloud services, data transfer costs. This complexity makes it challenging for organizations to break down their bills and really understand where their spending is concentrated. As well, costs are driven by Snowflake credits, which are based on the dynamic nature of the workloads. So think about your fluctuating query volumes or other seasonal demands or runtime variations. These things add another layer of unpredictability to cost forecasting. But as well, we have to recognize that things like warehouse configurations also add to the difficulty. So without proper management, organizations often encounter unexpected cost spikes that really hinder their ability to scale projects effectively. This complexity underscores the need for proactive strategies to monitor and optimize usage. Okay, went too far. What really makes this so hard and why organizations struggle, the reasons are many, right? But some of the top most frustrating to teams are, and one of the biggest, which is why I put it at the top of the list, is the lack of granular visibility into what drives costs. Like the lack of visibility to usage patterns. So for example, which user, which queries, which processes are driving up costs. We don't know what that is. It makes it difficult to allocate resources appropriately and forecast, things like budgets. Over-provisioned warehouses leads to wasted resources and inflated costs. And conversely, under-provisioned warehouses can result in performance bottlenecks, requiring expensive add-on credits to maintain service levels. These issues are compounded by data silos, right? Teams often operate independently, leading to fragmented cost tracking and reporting. And as a result, many companies rely on reactive measures, such as cutting resources after overruns occur, rather than proactively optimizing usage. This reactive approach limits their ability to forecast and budget effectively. And it really creates inefficiencies across the board. Okay. So what's the value of forecasting and budgeting anyway, besides the obvious, right? So let's look beyond just controlling costs. Forecasting and budgeting do more than just simply manage expenses. They empower organizations to allocate resources more strategically, based on business priorities. And by predicting future spend patterns, teams can plan initiatives with more confidence. They're ensuring, that their resources are available when they're needed. Additionally, these practices allow organizations to monitor performance against financial targets. So this fosters more accountability across the departments. And this alignment between financial goals and that operational execution really helps drive more long-term success. And so without historical data analysis or predictive tools, organizations find it hard to estimate future usage more accurately. This is especially true for businesses with dynamic workloads or those that are scaling rapidly. When it comes to Snowflake specifically, in Snowflake environments, effective forecasting ensures that cloud resources are utilized efficiently, avoiding both over provisioning and underutilization. So for example, teams can plan workloads more effectively by modeling credit consumption ahead of time. This in turn reduces the total cost of ownership while maintaining high performance levels for critical workloads. Furthermore, aligning technical capabilities such as compute power or workload type with those financial objectives ensures that every dollar spent on Snowflake contributes directly to those business outcomes. So now that we've spoken a little bit about the cost challenges with Snowflake, as well as the strategic value of budgeting and forecasting, let's sort of combine some of that into these key challenges of achieving that cost predictability. So it's not easy to wrap your head around pricing nor how to attribute that cost. Snowflake rather uses a pricing model based on Snowflake credits, which vary depending on a lot of things. Workload type. So is it a standard, or maybe are you using things like Snowpark optimized warehouses for maybe a machine learning workload or some other use case? Which instance are you using, or which t-shirt size, right, are you selecting? The amount and type of resources in those dictate various per hour credit costs. Then are you paying on demand or pre-purchased with discounts? This complexity makes it challenging to forecast costs more accurately. Additionally, organizations often struggle to attribute costs to specific teams or projects due to the limited granularity in the reporting tools. So for example, while you can see warehouse costs, breaking those down by individual jobs or departments requires a lot of manual effort or some third-party solutions. Now, if you've been using Snowflake for any amount of time and are tasked with resource management, one common issue is over-provisioning resources. So allocating a larger warehouse than is necessary for the workload, which leads to unnecessary spending, right? Misconfigured autoscaling is another culprit. While it improves performance, it can increase costs significantly if not optimized correctly. Idle resources. These are also a major concern, especially when warehouses are left running without active workloads. Implementing features like auto-suspend and enforcing query timeouts can help mitigate some of these inefficiencies. Let's not forget another cause of inefficient resource management is poorly configured code. So code inefficiencies like SQL queries that do full table scans on partitioned queries or cross-join sort of Cartesian products are often overlooked. So although Snowflake has some built-in budget features and resource monitoring, and although they're very good, these features provide daily notifications or alerts that they can suspend operations when credit usage thresholds are breached, but they react only after the fact. They lack that proactive anomaly detection capability to identify unusual spend patterns before limits are reached. These combined with other shortcomings increase the risk of cost overruns. This is particularly problematic for organizations managing large data sets or scaling their workloads rapidly. So as storage and compute costs, can spike unexpectedly. To address this, companies often turn to external cost monitoring tools or implement FinOps strategies to maintain better control over their Snowflake spend. Okay, so we covered quite a bit in these first few slides. So what I'd like to do here first off is show you Unravel's DataOps FinOps observability / actionability platform, which is purpose-built for Snowflake. And so you're seeing the UI here, and we actually easily connect into your Snowflake environment by running information schema queries on those essential warehouses that require monitoring. So nothing really intrusive from that standpoint. And what I'm going to do here is I'm actually going to focus on this Home tab first. And so what Unravel is doing is it's using its purpose-built AI to find where all of the inefficiencies are in an organization's Snowflake estate, which are preventing them really from scaling effectively, right? So the other thing we do is we connect to the billing piece from Snowflake so that we can get a little bit more granular and get that additional information around the bill, right? So if we take that first key challenge of how complex Snowflake pricing is and how can we effectively attribute that cost, I want to use that as kind of a first use case here. So actually, I'm going to not start on the Home tab. I am going to start on this Cost tab. We'll go back to the Home tab here in a little bit. But as it's painting here, there's several sub-tabs to this Cost tab. We're in the Overview tab. And in this section, you'll see some familiar metrics like you might find in the Snowflake UI, such as total cost, total credits consumed, a breakdown between compute and data transfer and storage, some trending. We can also get down to the warehouse level here as well. So again, you'll see some familiar metrics and information around the compute breakdown itself, and some of those trends, such as virtual warehouse compute costs, and other cloud service costs, even serverless, right? Beyond that, the total number of warehouses, average cost per that warehouse, and even the most expensive warehouses, and who those are, as well as some of the other breakdowns in terms of the percentage of the total estate that they represent. Now, if I move over here to the User sub-tab, so this is where things get a little bit more interesting. Again, we can see total users, average cost per, or average query cost rather, per user, top users by query cost, some cost trends and chargeback by user. So at the end of the day, who are some of the people or some of the users that we can approach or focus our attention on in order to start to understand where some of the cost drivers are? Because users ultimately are the reason for driving costs upwards. But we can get even more granular and attribute costs by leveraging Snowflake's object tagging, and attribute costs to other cost centers and business units to help drive awareness and visibility through these dashboards, or even porting out to your favorite, BI platform, be that Power BI, Tableau, Looker, etc. And then lastly, at this query level, right? So in the hierarchy of things, we've seen at the warehouse level a bit more granular with the users. And so now what does each user do, right? But they run queries against those warehouses. And this is where we can drill down into that sort of lower level. In the dashboards, you have, total queries, average cost per query, some cost trends around that. But also there's this query signature, which really is just a grouping of a specific query text. And for example, outside of this, other category, this light blue category, I have quite a few others. For example, here, this particular query signature accounts for, almost 3% of my total Snowflake bill, right? And then some trending in terms of those signatures and their costs. Okay, so where does all this deeper granular reporting and trending, where does it make a difference is really to be able to better predict and forecast spend, especially in real time, instead of after the fact, having to look at billing from past activity, pull some other information from perhaps information schema, correlate all that together, but also being able to leverage Unravel's alerting and anomaly capabilities in order to set some proactive real-time alerts for potential cost thresholds and budget overruns from that user or warehouse or project perspective. Or, getting alerted on some kind of an anomalous, unusual behavior that was detected. So, for example, based on historical data, I want to know if that $1,000 query is that normal or not. The ability to set up anomalous alerts based on intelligence. So, maybe as another example, the time it takes to complete a query used to be 30 seconds. Now it takes 5 minutes. That's some powerful stuff. But I digress a little bit here, going into the weeds a bit, but let's circle back to that homepage here. And let's talk about one of the other key challenges, which was all about inefficient resource management. So things like over and under provision warehouses, right? Idle resources, long running or timed out queries and poorly configured code. And the way I think I'll do this is I'm going to start here on this homepage, talk through a couple of things. So here you're getting a front row kind of executive level view of how things are going in your Snowflake data estate, right? Or really the health of your Snowflake environment. And so from this perspective, and what Unravel provides really at its core is, and what we do really well, and that is we want to provide insights into how you can potentially improve on 3 things, right? So we want you to be able to increase productivity, improve performance, and all while reducing cost wastage. And we do this by looking for inefficiencies. And maybe that's how your warehouses were configured, or how your queries are written, or maybe even some table or data level insights. And so I think I'll walk you through a scenario. So I'm an organization at scale. I've got pipelines that are doing a multitude of things. It could be, I don't know, large scale analytics for years and years of historical transactional data, right, to identify some kind of trend and patterns, or some other large scale data engineering ETL pipeline, to consolidate from multiple sources into a single platform like Snowflake. These use cases, they might require different warehouse configurations. Maybe those data engineers have a need for some heavier compute because they have some complex queries that they're performing, or maybe the real-time operational reporting requires a warehouse cluster that scales more dynamically with the demand. Either way, lots of different dynamic workloads require different warehouse scenarios. But again, it's up to the user to determine the optimal way. So what I see with customers at scale is that it's a very time-consuming task. And so they try to implement a one-size-fits-all. Maybe this is done through some policy that was determined by trying to understand, a best practice. And then the organization tries to use it as some kind of a standard. Now, a lot of time this goes unnoticed in terms of what pipelines are over allocated. And it's really unclear to the organization. So they say like, hey, what are some of the pipelines that can be optimized for cost predictability? So you'll be happy to know that What Unravel is doing is it's using, again, its purpose-built AI to find where all of the inefficiencies are, which are preventing them from achieving cost predictability more effectively. So what are we looking at here? So several insights related to warehouses. This is our insight analysis section on the homepage, and we're looking at the warehouses sort of subsection. But let's talk about the different ways to scale warehouses in Snowflake. First, we have the t-shirt sizes, right? The more commonly maybe referred to as scale-up architecture. Hey, I got a large, which gives me, this many cores, that much RAM. A medium, a small, something that gives me, less. This is where I'm thinking about my workload, running my heaviest, workload maybe. I need a lot of memory, I need a lot of CPU because I'm servicing my heaviest query. I'm a developer, especially maybe an inexperienced one, if given the option, will always pick the beefiest, t-shirt size. But I might not always need it. I'm not thinking about the cost. I just need my job or my query not to fail. Or there's scale out architecture. Auto scaling comes into mind there, right? Hey, I start out with a single extra small, but now over a period of time, I have 10 extra smalls, right? That's our classic concurrency use case. How many users at once do I expect to service? This is that, 9 to 5 operation where I have my heaviest user count during the day, but at night, fewer, so not so much. Keeping all that in mind, let's talk about a few things here. So Unravel provides several insights in this area. Underutilization. How does Unravel define that? A warehouse is underutilized when the workloads running on the warehouse don't utilize the full extent of the resources available. We're leaving dollars on the table. We're leaving resources unused on the table. Therefore, those workloads can run on a smaller and cheaper warehouse without performance degradation. That's key. Queries running on oversized warehouses. These queries require significantly less resources from their current warehouse. Warehouses with, the suboptimal min and max cluster settings. Some of these warehouses have a minimal cluster setting that's too high, and it causes cost wastage, or a max cluster setting that's too low, and it causes performance issues, right? Bottlenecks. Queries running on undersized warehouses as well. So I'll call out a couple other things here too. Each of these sections, whether it's underutilization or these queries and running on undersized or oversized warehouses, et cetera, they have 3 sections. And so for those FinOps folks or, FinOps conscious members of our audience today, what we're showing is 3 areas: wasted cost in the last 7 days, by not having the appropriately sized warehouse to your workload, but also untapped savings in an annualized perspective, right? So how much could I potentially save from that perspective? And really giving those FinOps folks the built-in dashboards, informing the user on where to focus your attention first, second, and so on from an optimization standpoint. So where do I spend my time optimizing my warehouses in the most effective way so that I'm running a leaner Snowflake machine, right? I'm freeing up resources, I'm freeing up space, I'm reducing my credit consumption so that I am able to make room for additional scale. Now, I just want to touch on another area here because I am mindful of our time. So the other thing is poorly configured code, and that really leads to wasted resources and spend as well. So more succinctly, inefficient queries that were identified, right, with opportunities to improve their performance as well as their cost efficiency. And so as you can see here, there's several categories of insights. We have things like filtering and joins and SQL anti-patterns, all inefficiencies and areas for opportunity to correct for performance, speed, and cost efficiency. So here, the point really is if you have inefficiently written code, which elongates a query from the time it takes to run, whether that's a join that's taking forever to process huge amounts of data unnecessarily, or some other inefficiency, unless optimizing your code is part of your strategy, you won't be able to effectively predict cost nor forecast appropriately from a budget perspective. Okay, so we've covered a lot of ground. First, we spoke a little bit about the cost challenges with Snowflake and how consumption is directly tied to that workload complexity. We also went through several points on why organizations struggle. So things like siloed data and limited granular visibility. Then we discussed the strategic value of forecasting and proper budgeting and how it extends beyond just cost control, right? To where you really must adopt more of a strategic resource allocation and facilitate more informed decision making. Then we kind of boiled it down, some of those key challenges of achieving cost predictability, like the lack of proactive spending controls, like those anomalous alerting features, inefficient resource management, like the over and under provisioning of those warehouses. And finally, we went through some quick live demo examples of how Unravel's purpose-built AI can really help you to identify inefficiencies in not only your compute, but in your code as well, in order to streamline your data operations from a cost predictability standpoint. All right, so again, in the interest of time, I know we have some questions, but real quick, if you think the things that I've been sharing with you today can help you, then you can go today. You can get your free Snowflake health check simply by visiting the URL here on the screen. So unraveldata.com/snowflake-health-check-request. Go ahead, check that out. It's free to you, absolutely no cost to do this. So I definitely recommend you to try out the product, see what life could be like if you're using Unravel for your data ops and your FinOps observability use cases. So yeah, let me take a couple questions. I know we have a few in the queue here. Let's see. So first question, how can historical data be effectively leveraged to improve the accuracy of future cost predictions in Snowflake environments? So historical data effectively leveraged. So the way Unravel does this is by analyzing historical usage patterns. It then attributes cost at those granular levels that we were talking about, right? And applies our AI-driven models to forecast the future expenses. It also identifies workload trends. It detects those anomalies and it refines predictions using real-time feedback. So it's constantly learning, right, in real time. This ensures accurate forecasts and actionable, optimization recommendations. This approach really has proven time and again to enable organizations to really proactively manage budgets, optimize their resource usage, and maintain that high prediction accuracy in complex environments like Snowflake. So next question. How does your solution address most common challenges organizations face when trying to accurately forecast Snowflake costs? Yeah, so like we were talking about before, cost forecasting is one of the biggest challenges, right? And by providing more granular visibility into costs at that app level, at that user level, the warehouse levels, Unravel really enables that more precise chargeback, I'd say, and the anomaly detection in near real time. Our AI-driven platform leverages again, those historical trends and that predictive analytics to forecast spending accurately. It provides automated recommendations for warehouse right sizing, that query optimization, and even governance to help organizations really reduce costs by in some cases up to 50% and maintain budgets more effectively. So last question. How does your solution help highlight the key metrics data management experts should focus on to transition from reactive to proactive cost management? Okay, so Unravel will actually highlight key metrics to help those experts transition to being more proactive and cost management conscious by focusing on that granular visibility, right? Focusing on the predictive analytics, focusing on those actionable optimizations like we went over in the demo. It also emphasizes tracking costs by query, by user, by warehouse. It monitors resource utilization patterns. It forecasts future expenses using those historical trends. And it offers the AI-driven recommendations for your workload tuning and your warehouse resizing to prevent that overspend and improve efficiency. So I know we're a couple minutes over time. I appreciate everybody sticking around and for the questions. Again, my name is Hal Sriver, and we'll see you on the next one. Thank you.